The next definition is a seismic gap. This is an area along a fault line that has had few earthquakes. So, if you look right over here, this is the 1989 earthquake, the famous one that we have discussed that happened during the World Series. So, if you look at all of these blue dots right here, okay, they represent certain amounts of earthquakes. Now, I know in the middle, it looks like there's a lot of blue dots, but there's not nearly as many as there are over here. Basically, we would expect this to be filled in with a bunch of earthquakes. Because when one earthquake happens, there's actually a lot of quakes that happen in that one earthquake, because it includes all of the aftershocks that are in there. So before 1989, this is this is that gap right there. And then look, immediately after the earthquake in the red, it fills in that gap right there. So a gap is what you use to make a hypothesis. So it's called the gap hypothesis. And this states that a section of an active fault that has had few earthquakes, and that means a seismic gap, is then likely to have a strong earthquake in the future. So basically what we could do is we can locate the seismic gaps, and we can use that as a jumping off point and say, okay, this is a hot spot to look at because it's very likely that they're going to have a strong earthquake. There's two ways that it can happen. There's when the plates shift and they move. They could do it in two different ways. They can just constantly be moving a little bit at a time, which is sort of unlikely, but that would be lots of little earthquakes. Or it could just get built up and build up that pressure, and then finally slide and then release a lot at once. And that is what tends to happen during these seismic gap areas. So we cannot make predictions about earthquakes in the same way that we can predict the weather. The weather, even though some people might say that scientists are not good at predicting the weather, all things considered, they are pretty good at it, and they're much better at predicting it than they are at knowing when an earthquake's going to happen. So we may not know. We can say something like in the next 30 years, there was a 85% probability that there will be a 8.0 earthquake or higher in the California region. That's something we can make a prediction on, but not even close to like the date, the month, the year. All those things are way too difficult to predict. Here's another image of that seismic gap right over here. So before the date of it right here, you could see the gap right there. That's called the Loma Prieta Gap because it's called the Loma Prieta earthquake. And then right over here, this is what it looks like after the earthquake. So basically you can just copy and paste this one little thing into there, and then that's what it looks like afterwards. And you can see that all those gaps have been filled in. You can see over here that there's another gap right over there, the San Francisco Gap, which as far as I'm concerned, as far as I know, has not been filled in yet. So that's one that we will look at in the future. Same thing with this Parkfield Gap over there. So we've talked about how every time there's an earthquake, it's not just one earthquake. There's actually a series of them. And those series of earthquakes that follow are called aftershocks. They are weaker earthquakes that follow a stronger earthquake. So if there's an earthquake, here's a bunch of all of these red dots, or orange bars right here represent the earthquakes that take place during one earthquake. So we can see that below here, this is background activity. None of these actually count as one. But over here, we see a mini earthquake, a slightly stronger one, gets weaker again. And then all of a sudden, we see this major earthquake right over here. So this is what's known as the main shock. It is the strongest of all the earthquakes that happen in the sequence of earthquakes. All the ones that came before are known as foreshocks because they came before. And then all these ones that come afterwards are called aftershocks. And you can see how they gradually get weaker and weaker as you go down. They sometimes get weaker and then stronger again, weaker and stronger again. But every time they get stronger again, they're not stronger than the main shock. If there is one that's stronger than the main shock, whatever the strongest one is becomes the main shock. And then afterwards, there will always be a series of aftershocks that follow. So that is the sequence of events that happens. And you can see over here that the number of earthquakes in the region of the main shock is represented over here, and then by year. And then, so this is when the main shock occurs, and then the aftershocks gradually decrease in strength as it moves along. This is a awesome 2 videos, which I'm going to attach and highly recommend that you watch, which shows all of the different major earthquakes represented by dots. And you could see this all throughout. This is something that you might have seen if you were to go to the open house at the Lamont Doherty Earth Observatory, because they created this simulation there originally, and then I believe it has been picked up and put in other museums as well. So if you want to earthquake-proof a house, this is a cool video that shows you how to do this. But the next thing that we need to worry about from an earthquake standpoint, what else causes damage? It is a tsunami. A tsunami is a Japanese word. I believe it just stands for like giant wave in Japanese. So it's a wave that forms when a large volume of ocean water is suddenly moved up or down. So a tsunami is always caused by an earthquake. Or, like you can see over here in this bottom layer right there, the volcanic eruption that takes place is what displaces the water. But there's almost always an earthquake that results with a volcano anyway. So either way, it's still working out where the earthquake is what's causing it. Now, the reason that the earthquake happens is you can see right here, this ground shifts down relative to that part. This earth moves up relative to that part. When this tract of land moves up relative to that part, it pushes all of that water upwards. Now, that water has to move in two different directions to level itself out. It'll move to the left and to the right. And as it rushes towards the right, towards land, that's where the earthquake comes from. And you could see how just a little bit of upwards out here may not look like much, but as it continues to get closer and closer to land, it builds up, builds up, builds up because it runs out of land and it continues to get bigger, and then it will have a huge landfall when it finally lands. So you can see just what I was talking about right here. As this shifts upwards, it's not easy to see. Out in the middle of the ocean, it may not look like much to you, but as it continues to rush towards the land, you can see how much bigger it'll get. And these are some exaggerated animations to show you what it looks like there. But real life version does tend to look a little bit different. Here's a slightly more realistic animation, which pretty scary, and you can see how this is definitely a city that has basically no seawall at all to prevent it. Over here, we can see that this is Japan during the famous 2011 earthquake that resulted there, and their seawall right here. They have a seawall. However, their seawall, the earthquake and the tsunami just happened to be taller than the seawall. So it did prevent some damage there, but not nearly enough, as you can see with all the damage that took place afterwards. Now, some of these are some footage that was taking place so you could see what happened. So on the bottom left, you can see all these cars are obviously driving towards the tsunami unwittingly, and luckily, those ones were able to turn around in time. That is during the 2011 Japan earthquake and tsunami that resulted. Not every earthquake results in a tsunami. Only the ones that result in the water will actually cause a tsunami to form. You could see on the bottom over here, this one was, I believe, in the 2004 earthquake that happened in Indonesia, and you could see it making its landfall, and how, I mean, before it lands, it just looks like a pretty big wave until you realize that that wave should not be that big near the coastline, and then how it rushes in and causes all that damage very quickly. These clips are from a movie called The Impossible. This is based on a true story about a family that was on vacation in Indonesia when this tsunami hit, and then they get separated, but they wind up finding each other later on. And while it is frightening footage, it is just exaggerated, Hollywood effect on it, but also it tracks real life things of what happened, and it just gives you a crazy visual example of what it might look like to be there. Very scary, of course, but I thought you might enjoy some of these two clips there to see the tsunami in action. And then we will watch a documentary based on this as well, because this is one of the most significant natural disasters that ever took place that we know about. So that's earthquakes and tsunamis.